Okay, meet my new system drive. Hi. So this video will be a really short one, and it is about zettabyte file system. But before you watch this one, I would recommend that you watch my weekend project up there above, right? It was about me building a really old, I built a NAS storage device, right? A network attached storage. And the way I did that, I got like a rack mount 19-inch 1 unit, quite loudy, not lousy, but loud box that has some kind of Fujitsu proprietary operating system on it. It has 4 hard drive bays, so from that perspective it's good. The CPU is crap, but overall it's a good x86 package, right? So I have liberated it from having a proprietary software installed, Debian on it, and it is basically going to serve me as my home NAS. The thing I do, right, is when you don't have like loads of money, right, then you kind of get along with scraps, right? And I'm not saying this as a bad thing. I kind of like to rescue older electronics, and by older electronics I don't mean crap that doesn't serve literally anything, right, or faulty electronics, but simply devices that still are fully functional and can be repurposed for something. This is, I wouldn't really call it my passion, but it is something that I do. And usually it gains me some functionality, gratis, because people kind of want to throw stuff into the garbage. But then again, they might as well give it to someone who can still make use of it. So the CPU from my network storage, if you didn't watch that video yet, is like Atom CPU, which on its own is already crap, but this is Atom from 2011, so even bigger crap, and it is only 2 cores, of course. So what can you do, right? So from that perspective, it's a little bit shit. But eventually I settled down on a scenario which kind of worked out for me, and this is that I took an SSD, a SATA SSD, and I have connected it to the internal USB 2 port, and basically I have installed the operating system on it, right? So I get roughly 25 to 30 megabytes per second of transfer speed on that SATA drive, because the bottleneck is the USB interface, right? But generally it turned out to be a really good hit for me, because the system doesn't really feel like it needs more. It could use more bandwidth, but generally the seek time is what matters the most for the operating system, and this is what I learned previously in my life, but in this case it was very, very, very obvious, because at the first time I tried to install operating system on a USB stick, that was very, very, very wrong. Then I tried to install operating system on a mechanical hard drive, which in theory can do 100 megabytes per second, but the system has worked from that drive quite a lot slower than from a 4 times slower SSD. And by 4 times slower, I mean it's plugged in a 4 times slower interface, right? I mean, the interface for the hard drive wasn't slow. It was SATA 3, I think. I think. Not sure, actually. Maybe it's SATA 2. But anyway, it's a lot faster than 25 megabytes. But the hard drives on their own, the technology, the spinning rust, right? It is quite a lot slow, so not that convenient for an operating system. But then again, these 4 bays gave me an opportunity to use some of the hard drives that I have had in my drawers, right? And once again, I got them all for free. Two of them are 2 terabytes, each like 450 days of operating time. So quite new actually. Just how much would that be? Like 1 year and a half, right? Of working time. So that's almost new. The other two are 3 terabytes, but those have more than 6 years of operational time. So those are nearing the end of the useful lifetime. They all have smart technology, SMART, right? So they all claim to be healthy, but they will need some of the monitoring in the following months because these older guys could die any day now. And them being equally old, at first I thought like I should do a RAID 5, which means that you have one spare drive that can die and without losing your data. And then I thought like, okay, maybe that's not the smartest idea because like if you take into consideration my luck, right? Both of them will die at the same time. And if not at the same time, maybe while I am buying a replacement drive for the first one that died, I will not be able to bring it in on time to replace the one that's already faulty, and the next one will die as well. That's just my luck, right? So I have actually decided to use RAID 6. And considering that I'm using ZFS, right, zettabyte file system, I'm going to use what they call RAID Z2. So the easiest way to remember what number 2 means is basically 2 spare drives, right? So in theory, I have 10 terabytes of storage on these drives, but in practice, I'm going to get 3.6, and the reason for that is because you can't really put in such a RAID array drives that are of different capacity, right? So all 4 will be used as 2 terabyte drives because that's the capacity of the smaller ones. So I have already limited myself to 8 terabytes in the beginning. And if you take into consideration that all hard drives, or at least mine do, mine are advertised with tebibytes, not terabytes. So in essence, you get less than 2 terabytes per drive, more like 1.8 or something like that. So when you make 2 spares, in the end, you get like useful storage close to 3.6, 3.7 terabytes, which is fine for gratis equipment, gratis electronics. I really cannot complain. This is actually perfect. Any day now there might be some other guy who comes along and says, "Look, I don't need this hard drive. It's old. I have used it for, I don't know, 3 years. I don't want it anymore. I now use only SSDs, and I will have the opportunity to swap some of my dying hard drives." So this is kind of good, right? Recycling completely functional electronics is good. Having 2 spare drives as a backup for your important data is also very good. And once again, if you haven't seen my video from the weekend, it's quite exciting. It took me like 15 hours to build my network storage in terms of hardware and the operating system. And just now I'm moving to the next phase. And the reason why I have been talking for 8 minutes is because the main part of this video is actually going to be so short that it wouldn't make any sense to release it without the proper introduction, right? So let me go ahead and show you what I'm going to do on Debian. So first of all, in order to install zettabyte file system on Debian, there is a small clash with licensing. Basically, OpenZFS or OpenZFS has a free software license called CDDL, but it is a restrictive license, just as GPL is also a restrictive license, and these two are incompatible. So basically what this means is that Debian cannot provide you with ZFS on their install medium, and you have to compile it on your own. and put the modules into the kernel. However, Debian did go ahead to the farthest that they were able in order to make it as easy as possible for us to install this, right? So what you need to do is first you need to enable the contrib. What do you call them? I was going to say directory, but I meant the package repository, right? So the first thing that you need to do is apt sources list, right? So what you need to do is put contrib on the end of all of these lines, right? So that you will enable the contrib directory and then do the apt update, right, to refresh your directory. I have unfortunately already done this because this is how I make these videos a little bit concise and faster, right? So what's next that you need to do is basically you need to actually that's the wrong command, sorry, pasting the wrong stuff. But that's the next thing that we're going to do. So the first thing you need to do is install Linux headers for your CPU, which is probably going to be the x86, right? So we'll type here AMD 64. If you have an ARM CPU, then go ahead and choose your ARM architecture. There are a couple of them, I think. You will need DKMS, that's the kernel modules helper. You will need some zfs-utils, and basically what is going to happen is that once it is downloaded, it will be compiled and integrated into a kernel tree, and then you can just ls mod the ZFS modules or simply reboot your system after installing this. It will take a little bit until everything compiles, but you can just go ahead once it's finished and reboot your system to make sure that everything works on a fresh boot, right? This is very, very desirable. And once you do that, then you will going to need to do lsblk in order to understand what you have in your network storage box thing, right? So SDE is my system drive, right? And as I said, I have two hard drives that are advertised as 2 terabyte drives, but in reality they are a little bit less, and these are advertised as 3 terabyte drives. So what you cannot do is that you cannot combine these, right? Basically the ZFS works on a block device. In theory it can work on partitions, so there is a way that you could utilize all of the available storage, but it is advisable not to put ZFS on partitions but on raw hard drives on their own, and let ZFS worry about everything required in order to maintain your data integrity, right? Just let it do its thing, right? Don't worry about wasting any data, because there is another way that you can actually utilize the excessive storage, the excessive 1 terabyte on each of these drives, if you are in a similar scenario as I am. So then what you need to do is basically type this command, right? So what this does, the zpool is command that creates a new pool, right? You will type the command create. There is a command here, ashift equals 12. This is a 4K hard drive block alignment command that will slightly improve your performance on basically any modern hard drive. And by modern, I don't mean like 5 years old, but there is a huge span of such hard drives that can be sped up a little bit by using this command. And you don't need the -f command if all of your hard drives are this equal capacity, right? But if I don't put F, I'm going to show you what will happen. The jaglenac here is the name of your ZFS RAID pool. So put whatever name you like. It will be mounted in / the name, right? This is where you choose how many drives you want spares. If you type 1, it will be just 1 spare, and in my case I would get 5.4 terabytes, but if I put 2 spares, I'm going to get well, 2 spares, right? And I will get useful space of like 3.66 terabytes, right? And then you need to type all of the block devices that you want to put into your RAID Z array, right? So let's go ahead and attempt to do this without the F switch. So there you go. It is going to complain that the devices are of different size, right? So what you now can do, right? You can just put the force switch, and what this will do is it is simply going to calculate which is the smallest hard drive that you own out of the 4 that you have requested to be added in this pool, and it will make all 4 of them of equal size to the smallest one, right? So let's go ahead and do this. It will not take too long, and we're already done, right? So let's what you can do now is check what has happened, and you will see that some partitions are on these drives, right? So zfs-disk, if you do let's go with sudo, right? Sudo zfs-disk dev cda. Okay, and now you can see that we have Solaris a partition, right? And a little bit of Solaris reserved. Don't touch this. Like, don't touch it at all. You will see that it is as large as the hard drive is. And if you were wondering what happened to the larger hard drive, right? You will see here that it is also taking up the entire space of my hard drive, but it is not actually utilized, because if you type df, you will see that we have roughly 3.6 or 3.7 terabytes, depending on how you calculate this, of useful storage, right? So we are already live and working, right? This is everything that you need to do, except for the compiling part, which depends on the speed of your CPU. The whole thing lasts like maybe 2 minutes, and you're done. You can start using the system. Of course, you will want to understand how ZFS works. You will want to monitor logs. You will want to monitor smart. You might want to set up your email server on this machine and make it so that it sends emails to you like daily about the health of your system, right? If you're doing all of this manually, right? After all, we can always install stuff like True NAS that also works on Debian, and it does basically the same thing, but through the graphical user interface. But I tend to do things manually, not because I am a masochist, but simply because this is how I learn more about how things function under the hood, right? Anyone can install a GUI software, right? And click please create some kind of a RAID array, and it will throw back a question at you: how many spares do you want? And you will pick it, and everything will be done, and you will not have to worry about anything ever again in your life. That's a bit of overstatement, but you know what I meant by that, right? So by doing things manually, you're going to do stuff like z pool. Actually, let's do sudo because I'm not sure if I need it. Zpool list, and here you can see that the total capacity of all 4 of our 2 terabyte drives, actually 1.8 times 4 is this, but in the real life, right, we get what we have chosen regarding to how many drives do we want to be able to fail at the same time. You can use RAID Z3 as well if you have many drives and all of them are really old. It is a plausible scenario for a home user that you have a lot of really old hard drives, and if you are so scared that they are going to start dying, and you have plenty of them, and you have the actual space on your motherboard to plug them in, then by all means go ahead and use 3 spares if you so desire, right? The problem with having only 1 spare and a lot of old hard drives is simply when it dies, your data will be safe, but just for as long as it takes for another one to die. So if you believe and trust your system, or maybe have another backup somewhere, then it may be a better idea to use only 1 spare. So when that one dies, you will have some time to replace it. And if the field collapses because another one died in the meantime, well then, you're going to restore from some other backup. So from that perspective, it is what it is. That's basically what I wanted to do. What I am going to do next is I'm going to benchmark what this Atom CPU is capable of. So basically what my actual network throughput is, right? From that perspective, I mean, if I get like 100 megabytes per second, this will be like awesomeness of the awesomeness. But if I get stuck with like 20 megabytes per second, I may reconsider the bottleneck, right? Which is most probably going to be the CPU in this kind of scenario. I think this is pretty much everything I wanted to show you. And from this point onwards, I'm going to use my home lab to build on top of it. First of all, I'm going to restore some of my files onto this new pool, and then I'm going to consider how much. Oh yeah, one other thing that I wanted to tell you. Having 2 terabytes and 2 terabytes and 3 terabytes and 3 terabytes means that all of them are behaving as 2 terabyte hard drives. However, you can replace the 2 terabyte one with, let's say, 3 terabyte drive in the future because you managed to get a hold of one, and still you will have, you just unplug it and put a new one, a bigger one like this one, and the system will rebuild this drive with the data that was on the one that you have unplugged, right? And then you will eventually replace this one with 3 terabyte one as well. So at this point you will have 4 drives of equal 3 terabyte size, right? But still they will be behaving as 2 terabyte size. And then there are ZFS commands which will tell them all that now they have more space, and please expand the RAID Z field to fill up the entirety of all of the drives, right? So you can do this live without needing to export your data somewhere and delete the entire RAID array and make a new one, right? You can do this live. Also, there is another option that came just 1 month ago, literally in January of 2025, and this is OpenZFS version 2.3, which now supports the expansion of the RAID Z array. And what this means is if you have a couple of drives between 2 and more, you can now literally add another one to the field and tell this entire field to expand onto the new one that was added. If you have selected in the beginning when you created the field that this is going to be RAID Z1, it will stay RAID Z1 forever. If you have chosen RAID Z2, it will still stay RAID Z2, right? So in my case, I have 2 spares, and if I add another drive, I will still have 2 spares, any 2 spares, right? But the entirety of the capacity will increase by roughly the amount of the new drive minus a little bit. So this is kind of awesome, and I think this is great news for home users, because home users often don't have the vision of how much ability will they have in terms of finance to expand their RAID array in the future, right? What you can do is basically, if you have, like, let's say most of the desktop computers have roughly 3 SATA ports. Some of them have 4 SATA ports. But if you feel limited with the amount of SATA ports on your desktop machine, and eventually you get your drives filled up and you need more storage in your RAID array, you are absolutely capable to move to another machine that has more of the SATA ports, or simply you can purchase a SATA card that plugs into the PCI Express and get more of the SATA attachments, right, ports, for more of the hard drives. Of course, if you have the physical space to host the hard drives inside your case. So that's a whole another story. But basically what ZFS gives you as an opportunity is to expand slowly and as affordable as you can do it for yourself, right? So from this perspective, I think I have given you enough things to consider, right? It is very easy to get going, even if you only have well, basically, if you're starting with RAID Z1, then you will need 3 hard drives in the very beginning. So that is a slight consideration, right? But other than that, you're good to go and grow in the future, right? Let me know what you think about my video. Let me know what you think about a little bit of research that I did here. And let me know what you think about my other video that I have linked above, right, a couple of times, maybe, I have no idea. And I'm going to see you, in the next video.